Imagine you're an astronaut sitting in a spaceship heading towards a Mars and suddenly your software fails, screen goes unresponsive. This is the disastrous thing that nobody ever want to see. That's why NASA has set these 10 crucial coding guidelines which helps them to write a space-proof code, because in a space there is absolute no room for the errors. In this video we are going to see all of them. First thing first, NASA avoids the complex control flow construct and prefers a simple over it. For example, a go-to statements or the recursion call should be avoided at any cost. Instead of that, they prefer a simple for loops and avoid the conditional logic. And all loops must have fixed upper bound. This not only avoid the infinite loops but also ensure that the code will complete in a predictable amount of time. Knowing that time beforehand avoids any possible system crashes. Rule number 3, do not use the dynamic memory allocation. NASA do not use the dynamic memory, also known as a heap memory, meaning they don't use the commands like malloc that causes the memory leakage problems, which can lead to a fragmentation or the system crash in the worst case. So instead of that, they use a static simple memory. One good example can be defining an array of a fixed size at a compile time and possibly assigning a value to it, because a heap memory has a really good potential of causing memory related problem because of the developer's mistake. Number 4, limiting the function size. NASA believes that the function should be small and do one thing at a time. Ideally, it should not be longer than 60 lines of code. This makes them easier to read and test and debug the code. If the function gets too long, they split into smaller ones. Number 5, use minimum 2 runtime assertion in a function. Assertion is a logic that is based on a fact, but when you use at a runtime, it can have a side effect. For example, in this case, we are asserting the x value and the x value is being also modified in the same function. This can introduce problems like overcomplicated code and the reduced readability and unnecessary checks that clutter your function. Here, the ultimate goal is to reduce the uncertainty at a runtime. Number 6, restricting the scope of the data to the smallest possible. Restricting the scope of the data to the smallest possible means declaring a variable in the smallest scopes where they are needed, which can improve the code readability, maintainability, and reduce the chances of errors. NASA uses a static code analysis tool to automatically check for the code errors, style violation, and the potential issues. These tools provides an extra layer of scrutiny beyond the human review. It checks for the multiple violations, and there are tools available which has the predefined standards or the policies in it. For example, NASA uses this tool called ICOS, which is open sourcely available on the GitHub, which basically checks for the standard practices of the CPP languages. It's an analyzer tool which is based on the CPP theory of abstract interpretation. For example, a violation like checking the return value of a non-word functions or casting its value to avoid to indicate that the return value is a useless can be easily detected with such an analyzer tool. Number 8, use the preprocessors sparingly. Preprocessors are the directive that are the instructions that are processed before the actual compilation of a code begins. They can do things like defining a constant or create a macros, which are like shortcuts for the code. First, they are applicable to all the files in which they are included, leading to an unexpected behavior. Second, the macros that we write have a type checking, which can cause hard to find bugs. For instance, and accidentally pass the wrong value to a micro, it can give an error that would cause a program to crash. When your program crashes and your runtime environment is a space, then it is very difficult to restart it again. Number 9, limiting the pointer usage. We all know that how hazardous pointers can be if they are not handled properly. Pointer stores the address of an actual variable, and inside that address of actual variable's value is stored. So you can actually change the value of a variable with using a pointer reference, which is called as a dereferencing, and you can modify the value of another variable through it, which is not an safe practice to do. Usage of pointer can lead to an overly complicated scenario. For example, in a CPP, there is a special type of pointer called function pointer, using which you can call a function with some custom values. And the final rule, whenever you are compiling your code, compile it with all the warnings, because with that you get an overview of all the violations or all the possible failures that can happen at a runtime, and you can fix them before you deploy it to your production. With that, thank you for watching this video. If you found this video useful, then please consider subscribing to my channel.